This is the video for 2.1 and 2.2. Equivalent equations are equations that have precisely the same solution. So for example, 1x equals 3 is the exact same thing as 2x equals 6, because for both of these equations, the value of the variable is 3. When we say isolate a variable, what we are saying is get the variable by itself on one side of the equation with a coefficient of 1. So when we say x equals 3, what we're saying is 1x equals 3. And so how do we do this? How do we isolate a variable? We use inverse operations. And what exactly is an inverse operation? That's an operation that undoes another operation. So for example, addition undoes subtraction, and multiplication undoes division. So let's look at example number 1. Solving an equation using subtraction or addition. This 13 is connected to this variable through addition, and so I want to undo this operation using subtraction. So I'm going to subtract 13 from both sides, and when I do so, I get 14. And so x equals 14. And then how do I check my answer to make sure I'm correct? I have to plug it back in. And I have to ask myself, when x is 14, is this equation true? The next example, this 3 is connected to this variable through subtraction. And so I want to undo this operation. So what am I going to do? I'm going to add 3 to both sides. And b is -4. So go ahead and hit pause and work out these on your own. The answers are -8. The next one is -6. And this last one I haven't worked out yet because I actually want you to watch me work it out. So you probably solved this by adding 3/2 to both sides. And if you did that, you're not wrong. However, I'm going to teach you how to solve this equation in a different way. And this way may seem more complicated right now, but please trust me when I tell you that solving this equation this way will make the math a lot easier when the equations get more complicated. And it's a lot easier to learn this concept now when the equations are simpler. So this is how I want you to solve these. I want you to look at this and I want you to say, well, I have a fraction and I don't want to have a fraction, so I need to get rid of the fraction. And I don't want to add the fraction, I don't want to do operations with the fraction, and I also don't want to change the fraction to a decimal. A decimal is just another form of a fraction. And so what I want to do is get rid of the fraction. So what I'm going to do is I'm going to multiply each term by 2. And when I do that, I get this. But let me make sure you fully understand why and what I did. I said I want to multiply each term. So look at what happens when I multiply each term by 2. My denominators cancel out. And that's my goal. That's what I'm trying to do. And then that's what I'm left with. And so then how do I solve it from there? I'm going to add 3 to both sides. And then I divide both sides by 2. And there's my answer. So that's how I want you to solve those problems. So if you didn't solve it that way, I want you to hit pause on the video right now and go ahead and redo it. But let's move to the next example, example number 2, solving an equation using multiplication and division. This 4 is connected to this variable through multiplication, and so I want to undo that operation using division. And so I have 1.6. And if there's a decimal in the original problem, it's okay to have a decimal in your answer. This next example, this 4 is attached to this variable through division. So I want to undo this operation through multiplication. Okay, so go ahead and hit pause and do these on your own practice problems here. Okay, here are your answers, and notice this one I left as a reduced fraction, but this one I went ahead and kept it as a decimal because, again, when there's a decimal in the original problem, it's okay to have a decimal as an answer. Otherwise, you do not want to convert to a decimal. You want to go ahead and leave it as a reduced fraction. We have to get comfortable with fractions. Okay, next example, and I know it seems like I'm moving fast through this and I'm combining sections, but this should all be review. So let's go on to example number 3, solving using reciprocals. 4/5m equals 28. Again, I want to get the variable by itself on one side with a coefficient of 1. Right now I have a coefficient of 4/5. So how do I make this 4/5 1? I multiply it by the reciprocal. So I'm going to multiply it by 5/4. But what I do to one side, I have to do to the other. So then when I cross reduce, that's going to become 1m. 1m equals 28 times 5/4. And then again, you want to cross reduce as much as possible to make your math easier. Work smarter, not harder. Work efficiently. So m is 35. Okay, so go ahead and hit pause and do this on your own. Okay, I want to go ahead and work it out for you so you see what I'm doing. I have 3/4 times x, so I'm going to multiply both sides by 4/3. Now when I do that, I can cross reduce over here and I get 1x, which is my goal, to get the variable by itself on one side with a coefficient of 1. And then I have 12, I'm going to put that over 1 just so it's easier, 12/1 times 4/3. Again, do less math. Cross reduce if possible. It'll make your computations easier, and you want to use your calculator as infrequently as possible, so cross reduce. Okay, last example, solving a two-step equation. What you want to do in these situations is you want to circle out the term that has the variable, and then you want to deal with that term last. So I want to get everything away from the variable, but I want to deal with the term that actually has the variable in it last. So I'm going to start with this positive 3. So it's plus 3, 2x plus 3. So what's the opposite of addition is subtraction. So I want to subtract 3 from both sides, and then I'm left with 2x equals 12. And then what do? I divide both sides by 2, and I have x equals 6. Most of the time when algebra students struggle with these types of problems, it's not because they don't understand what to do, it's because they mess up in their math. Take it line by line and show all your work. Okay, and this example here, think of it this way. I have a denominator and I want to get rid of the denominator. And so what do? I multiply both sides by the denominator. And in doing so, this is what I get. And now what do I want to do? I want to add 7 to both sides. And here's my answer. Oops. Okay, go ahead and hit pause and work out these on your own problems. Okay, on this one, if you went ahead and solved by adding 3 to both sides and then multiplying both sides by 2, again, you would not be wrong, but that's not how I want you to do this, okay? And I know this seems more complicated, but once again, I promise you, you'll thank me later when these equations get more complex and you know how to do this. So I want to get rid of the denominator, and so what I'm going to do is I'm going to multiply each term by the denominator. And when I do so, that's what I get. And then I add 6 to both sides, and I get x equals 16. If you have any questions what I did, again, I'm multiplying each term by 2. And if you need to work it out like this, please do so, at least for now. I'm multiplying each term by 2. And so then what happens? My denominator cancels out, which is what I'm trying to do. And then I add 6 to both sides. And finally, on the last one, I have a denominator of 4. I want to get rid of it, so I'm going to multiply both sides by 4. And then I'm going to add 2. So the only thing that's probably new in this lesson or in these lessons, this 2-1 and 2-2, is probably this. And what's new is what I'm asking you to do by multiplying the denominator out. That's probably new, but that's how I want you to do it. And again, you're just going to have to trust me. I work with Algebra 2 students that still struggle with this. And so I want you to cement your understanding of this process now before these equations get more complex. Okay, so go ahead and stop the video and work on your homework. Let me know if you have any questions. Shoot me an email.